All right, so I'm recording G period so that anyone who needs to see it can see it. We're on section 2.5 for those of you joining us and for everybody who's in here. And 2.5 is on complex zeros. So we just spent a whole bunch of time dealing with normal real zeros. Now we're dealing with complex zeros, which means that we're gonna see I in a lot of our answers today, the imaginary number. I erased a little bit more of my notes from yesterday than I wanted to. Yep, I erased what I wanted to show you, but that's okay. Remember yesterday, this problem A is very similar to what we did yesterday. I've got a given zero, so I'm telling you that one of the zeros is 2, and then it says find all the other zeros of the polynomial. The first thing we always look to do is factor, so I'll even make a little note off to the side. So you always look to factor. Factoring is the easiest way to solve for 0, so if we can factor, that's what we want to do. On problem 1A, I can't factor that. There's no way to factor that. I can't do that. So instead, I want to find my possible rational roots. Possible rational roots. Again, I'm sorry for erasing too much or else I'd show you what we did yesterday, but our possible rational roots are where we do our P divided by Q. Ooh. Plus or minus P over plus or minus Q. To remind us, P is the constant, the number at the end. So we're going to write all of the factors of the constant divided by all of the numbers, all of the factors of my leading coefficient. That's my Q. So not all of these will work. It's just a list of possible ones. And from that list of possible ones, we're going to find what does work. So I could have possible factors of 6 include 1, 2, 3, and 6. So you ask yourself what multiplies by 6. Those are your factors. My leading coefficient, if there's nothing in front of x to the third, we assume that it's 1. So factors of 1 are just 1. It's nice we made this easy. We now divide everything on top by everything on bottom, which is just all of these numbers divided by 1, which is just themselves. So we actually have a nice easy list of a ton of whole numbers. I could have positive or negative 1, 2, 3, or 6. Those are my possible rational roots. Once we make that list, we have to find one of those that works. So I'm going to plug in one of these numbers to my original equation to find if it equals 0. We learned the factor theorem yesterday, which means if you plug a number in, and you have this above, so you don't necessarily have to write it. If x minus k is a factor, then f of k should equal 0. In real people words, that means if x minus 1, if 1 is a 0, then if I plug 1 into my equation, it should give me 0. So now we're doing some guess and check. Hint, I always start with the smallest number. Start with the smallest number. Why would I go to 6 and cube 6 for no reason, right? Let's cube 1. That's way easier. So I'm going to do that off to the side. I'm hoping it'll be pretty quick, but I'm going to start with positive 1 and see what happens. So I plug 1 in, and I do 1 to the third minus 6 times 1 squared plus 11 times 1 minus 6. Okay, plug in, start solving. I get, oh, I'm so sorry, guys. Why'd you let me do all that? I did way more work. I already told you it was 0, didn't I? It's 2. What am I doing? You're gonna have to do this in a second. I got a little excited. I'm so sorry. Janae is laughing at me.
Because I thought you were doing something wrong, but if I would have tried to correct you, I probably would have sounded like dumb. So no. I was just going to let you do it.
Yep, just let me do it. I did way more work. I'm so sorry, guys. We already know the 0. We're going to have to do that in a minute. We're going to have to do all that work in a second, but we already know our 0 is 2. So we're going to skip all of these steps and go directly to synthetic division. We're going to synthetically divide. We are going to use these steps in a minute, so I'm not going to erase those, but I am erasing all the other work. 2 was what would have worked. I was going to say, I don't remember doing this earlier. I did it on another one over here. Okay, that's all right. Synthetic division. We divided yesterday, but in case we forgot or you slept overnight and you can't remember, that's all right. Carry all your coefficients down. 1, -6, 11, -6. Carry down our 1. We multiply the 1 times the 2 in order to get what goes under 6, so that gives me 2. -6 plus 2 is -4. I see us all getting it all done on our paper. Awesome job. -4 times 2 is -8. 11 minus 8 is 3, and then 2 times 3 is 6. Ooh, nice. -6, +6 gives 0. And that's what I want. I want my remainder to be 0. Okay, now once I've done my synthetic division, now we'll write this as our equation. I've got x squared minus 4x plus 3. And now I want to ask myself, can I factor? If I can't factor, then I quadratic. I will add that to my list because I will come back to this list later. So after we synthetically ask yourselves, do I have to factor or is it quadratic formula? We can factor this one. Awesome. What does this factor down to be? Awesome. X minus 3, x minus 1. And so what are my zeros? 1 and 3. Awesome, Cleva. 1 and 3. And then we also have to list the 0 that was given to us. So we're also going to list my 0 of 2, 1, and 3. Okay, we did an example with all real numbers because now I'm jumping right into the deep end and we're doing it with imaginary numbers. It's the exact same process. We're going to synthetically divide and then we're going to factor or we're going to quadratic formula. However, when I have a complex number, like in letter B, I have to use its conjugate as a 0 as well. Any questions? I forgot to ask. Any questions on A before I move on to B? Okay. Do you remember the word conjugate? If I have x plus I, what's the conjugate of x plus I? X minus I. Very good. Both of these are going to be zeros. The reason why is as we start synthetically dividing, it's going to get really messy. And so we need to clean it up with the conjugate. So I'm going to synthetically divide twice in order to get real answers. It does not matter which one you start with. I'm going to start with the one they gave us. So I'm going to start with 1 plus I in my house of my synthetic division. I'm going to carry down all my coefficients. Everyone good so far with my setup? All right, now we're multiplying. So carry down your 1. That's the easy part. Now I have to multiply 1 by 1 plus I. Okay, that's not hard. That's just 1 plus I. I was dramatic with how I wrote my plus I. Yep, just like that. Because I want to symbolize to myself and show that I can't combine my I with my -2. Only the 1 goes with the -2. Just like we did above, we add or we combine what's in that column. So I'm adding -2 and 1 to get -1 plus I. The I didn't have any friends to combine with, so he just stays by himself. Okay, continue the process. Now we're multiplying -1 plus I times 1 plus I. Ooh, we may need to do some scratch work off to the side, should we? If you can do this in your head, awesome. As you can tell, my brain must not be all the way there today because I can't. Distribute, distribute, FOIL it out. Mm-hmm.
Yeah. Right.
It would be pretty good. I'm sorry you're not though. -1 times 1 is -1, and then 1 times I is I times -1 is -I, and then I times I is I squared. This is helpful because all my i's cancel out, and I get -1. What's I squared the same thing as? -1. So I've got -1 plus -1 or -1, which gives me -2. I did all that scratch work to just put -2 underneath that -1 on my synthetic division. Everyone keeping up? We all on board? Okay, -1 minus 2 is -3. Multiply again. We multiplied -3 times 1 plus I. So I've got -3 minus 3I. 6 minus 3 is 3. Carry that minus 3I down. And then now I need to do 1 plus I times 3 minus 3I to find out what goes under that 6. So I'm going to go off to the side and do scratch work again. This time I'm multiplying 1 plus I times 3 minus 3I. 1 plus I times 3 minus 3I. Distribute, FOIL. Three minus 3I plus 3I minus 3I squared. I's cancel. -3I squared becomes +3. Very good. And then 3 plus 3 is 6. Ooh, nice. I could put 6 under -6. Oh, solid, it equals 0. Which is what we want it to equal, right? If it didn't equal 0, we would have a problem because then it wouldn't be a factor. All right, buckle up because we just did a lot of hard work, but that was just our first synthetic division. We did the first 0, 1 plus I. Now we have to do its conjugate. If I were to go right here and write this out as a polynomial, I'd have like x to the third and then -1 plus I x squared. That is so messy. The whole reason we get to use a conjugate is it's going to clean it up, okay? So let's multiply by 1 minus I, or do our synthetic division of 1 minus I, and then see what we get. So now 1 minus I goes in my house. And I just do a synthetic division right underneath the synthetic division I just did. There's no reason to start a new one or do anything crazy. Do it right where it was. This time, though, you don't need to include the 0 because it's a remainder, and we don't need to have that in the problem as I keep going. All right, draw my line, carry down my 1. So now I'm doing 1 times 1 minus I. Okay, that's not hard, 1 minus I. Oh, nice, -1. Cancels out with +1, and the positive and the negative I cancel, so I get 0. That's a real number. Now I do 0 times 1 minus I. Well, anything times 0 is still 0. -3 plus 0 is -3. We doing okay? Now -3 times 1 minus I, so we distribute that -3 to my 1 minus I. That's -3 plus 3I. Oh, and again it cancels. The 3's cancel, the 3i's cancel, 0. That's my remainder. You can tell that you're done because you have all these real numbers here at the end. And if you do your multiplying correctly, you should have all the real numbers at the end. Now, normally if I started with x to the 4th and we did a synthetic division, we'd be down to x to the 3rd. But I did synthetic division twice. So now I should not be at x to the 4th, but I should be at x to the 2nd. We go down 2 because I went twice through synthetic division. Is everyone okay with that? So x to the 2nd plus 0x, don't write that, that's redundant, minus 3. This is equal to 0, so we can solve for 3. And this one I didn't write as an option, but it's not factored, it's not quadratic formula. It's like solving using a square root, but that's not a cute little name like factor or quadratic formula, so this is just another way you can know to solve it. Add 3 to both sides. X squared equals 3. Square root. X equals plus or minus root 3. Whew, so my zeros for this, my zeros are what I was given, x plus I, or sorry, 1 plus I, 1 minus I, its conjugate, and then plus or minus root 3. Those all are my zeros. All right, questions so far? Let's do another one. When you're ready, flip your paper over, scroll down on your notability. We're on items letter C. What's my given 0 here? 4i. Is that imaginary? So I have to use its conjugate. So what's its conjugate? Negative 4i. Very good. So we're going to do exactly what we just did before. 2 synthetic divisions, 1 for 4i, 1 for negative 4i. This one's actually easier because it's not plus anything. It's just the I. It's just 4i. There's no additional pieces. So this one you'll probably find a little bit easier. So I'm going to set up my synthetic division, 4i, and then 1. Oh, there's no x to the third, so I'm going to use a 0. 13. Oh, no x, 0, and then negative 48. Questions so far? All right, start synthetic dividing. I'll talk through it. If you don't need it, you can just tune me out. If you do need it, listen. Carry down my 1, multiply by 4i, I get 4i. 4i plus 0 is still 4i. Now I do 4i times 4i to get 13, or sorry, to get the number that goes under 13. 4i times 4i, 16i squared. And we know I squared is negative 1, so I get negative 16. Good with that? 13 minus 16 is negative 3, times 4i is negative 12i. 0 minus anything is just itself, negative 12i. And then multiply by 4i, and I get 4i times, you get what? Perfect. Thank you, Jared. Positive 48. Well, I need to write that out if Jared helped me on that. Oh, and that's actually really nice because if I had a negative 48 and now I have a positive 48, they cancel and I get 0. And that's my remainder. Again, a hint, now that I have i's in here, you know that you should do another synthetic division. Your answer should never have i's in it. Do not give me answers with i's in it. So we are going to do our other synthetic with the negative 4i. Again, I see us working through it well. Carry down my 1, multiply by negative 4i. Oh, nice, those cancel. 0 times anything is 0, so I get negative 3. Negative 3 times negative 4i is positive 12i. Oh, and those cancel, and that's my remainder. Nice. And we actually just got this, didn't we? Yeah, you're probably like, am I going crazy? Nope, we got the same answer each time, which is x equals plus or minus root 3. I don't need to show any work because I just literally did it last step. So my zeros here are 4i, negative 4i, root 3, negative root 3. And you can write them like plus or minus both of them, plus or minus 4i, plus or minus root 3. Whatever makes you happy, but I should have all 4 of those. All right, doing okay so far? All right, let's keep rolling. This next one says, write the polynomial function, multiply it out. If it says don't multiply it out, we don't have to, but it says multiply it out with zeros 2 and I and containing negative 1, 8. So if it didn't tell us this point, we would normally just do this. We'd say y equals, and we'd have parentheses for all the zeros. My 2 would be x minus 2. We cool with that. My I would be x minus I. Wait, why did I put another set of parentheses? Why do I have 3 sets of parentheses? Conjugate. What do I write here? X plus I. Okay, the only thing is, since I gave you a point, I gave you an x and a y, we have to find an a coefficient out front. We're going to plug in our -1 for all my x's and my 8 for all my y's. And then I'm going to find the variable I'm solving for will be that a. Very much like vertex form, but the polynomial form is I just do the zeros and I put an a out front. Everyone okay with that? All right, let's start plugging. All right, my x, I'm going to plug in -1. My y is going to be 8. And then we're just going to simplify. -1 minus 2 is -3. Oh, I can't combine that -1 and -I, so we're going to multiply. Multiply, 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 multiply. 1 minus I plus I minus I squared. Ooh. The i's cancel, and then that -I squared becomes a +1. So I've got 1 plus 1, which is 2. A big mistake that happens here sometimes is we forget that we were multiplying all these numbers. So you want to add them. Don't add them, we're multiplying them. So -3 times 2, I get a times -6. And then we can divide by -6 to get my answer. So a equals 8 over -6. And we actually can simplify that to get me -4 over 3. Any questions on that? Okay, we're not done though. We're gonna plug that a in. Everyone okay with how I got a? Plug your a back into the beginning, and then we are gonna multiply it all the way out. Multiply everything together. I'm still going to have my x and my y in there. So I've got y equals -4 over 3, x minus 2, x minus I, x plus I. But now I want to get it all the way multiplied out. So it's like, you know, something x to the third plus something x squared plus something x plus something. The hint I have for you is don't get a fraction involved until you have to. Wait till the last minute to get that fraction involved. I would probably do your x's and i's first. Then whatever that is, multiply that by your x minus 2, and then do your distribution. Your distribution, did you hear me say that really weird? Your distribution with the -4 over 3. Cool. Y equals -4 over 3, x minus 2. This becomes x squared, or sorry, yeah, x squared plus xi minus xi minus I squared. Which becomes x squared minus 1, -x squared, sorry, -I squared is negative times -1, which is +1. Nope. Yes, it's +1, which is why it should be positive there. Please don't get me. Distribute your x minus 2 to that x squared plus 1. Y equals -4 over 3, x to the third. I'm going to put mine in the right order. So I'm going to do minus 2x squared and then plus x and then minus 2. I just rearranged it a little bit so it was in the nice order. Are you guys okay with that? Okay. And then distribute that -4 over 3 all the way through. -4 over 3x to the third plus 8 over 3x squared minus 4 over 3x plus 8 over 3. Any questions? Okay, we're gonna do a very similar idea for the next one, but I don't wanna multiply it out at the end, so we're not going to. Just for sake of time, I'm trying to get to as many problems as possible. And we're in here until 2. Can I move on? Okay. Very similar. This one says my zeros are 1 and then 1 plus 2i. What's the conjugate of 1 plus 2i? Good. Make sure when we write this in there, we do it like that. So I'm going to be very careful. I've got y equals a, x minus 1, x minus, I'm going to put it in parentheses like this. A lot of us are tempted to do x minus 1 plus 2i and then x plus 1 minus 2i. And then that's where things get to be trouble. So don't change too many signs or else you're going to be wrong. And then I'm going to do x minus 1 minus 2i. Don't forget to put your x and your y in, and then we're going to solve for this a. My iPad is being so weird. Stop. That's a personal problem, though, not yours. Okay, a, x minus 1, x minus 1 plus 2i. My x is negative 1. And then this time my y is 4. I gotta do all my multiplying. 4 equals a, negative 2. And this is negative 2 minus 2i. And then this is negative 2 plus 2i. Everyone okay with what I've done so far? Make sure you're careful with your signs. And then I'm going to distribute that negative 2i, and negative 2 plus 2i. Distribute those two together. 4 minus 4i plus 4i minus 4i squared. The i's cancel. Then negative 4i squared becomes plus 4, so now I get 8. So I've got 4 equals a times negative 2 times 8. Negative 2 times 8 is negative 16. Hang in there, we're almost done. Divide by negative 16 on both sides. I get a equals 4 over negative 16 is the same thing as negative 1/4. I know this is not the most interesting, guys, but you're doing a great job hanging with it. Are there any questions? This isn't hard, I don't think, like difficult level math. It's just a lot of steps and you have to be really careful with things. So if you miss a negative or if you miss plugging something in right, then like you can really screw up the whole problem. So this is just like, take it slow, take it careful, think through. Let's plug it into the equation. And again, I don't feel like solving this out today, so we're gonna skip it. If we can, we'll look at it tomorrow. If not, I think we'll all live. X minus 2, x minus 1. X minus 1 plus 2i, and then x minus 1 minus 2i. And that a is my negative 1/4. Again, if we want to, we can multiply it out, but I don't want to. Okay. We have 3 more problems. See how much we can get through. We have 20 more minutes. Why do I always have more time with you guys? I feel like in F period, I never get through as much stuff, but that's okay. Okay, this is find all the zeros, and this is what I started class doing because this is how I ended the last class, and I forgot that I had to build up to it. So this list that I started with you guys in the first problem, and then it was silly because I didn't need to do half of it. We need to do all of these steps on these problems on number C for letter A and B and C. So first thing I asked myself is, can I factor? Can we factor on letter C, A? The reason we can't is it's an x to the third. If it was x squared, we for sure could factor it all day, but we can't. So if we can't factor it, then we're going to do our PRRs, find our possible rational roots. We did review this just a minute ago, so remember that it's my plus or minus p over plus or minus q's. My p is the constant, so plus or minus 1 and 5. And then my q's is my coefficient, my leading coefficient, which is 1. Now, last class was a little confused on this, and then I think I didn't do a good job explaining it. You have to divide all of the numbers on top with all of the numbers on bottom. So the reason I just rewrite the numbers on top over again is because anything divided by 1 is just itself. All right, I got a lot of free faces. Put them back up, please. Thank you. Thank you. Okay, 1 and 5. This time I didn't give you a 0, so we have to check. We have to check and see what it is. And this is where I said we got to start small. So let's start with 1. If 1 doesn't work, we're going to try -1. If -1 doesn't work, we're going to try 5. We'll go through all of them if we have to, but I don't want to. So let's start at 1. Plug in. I'm going to do 1 to the third plus 4 times 1 minus 5. Okay, 1 to the third is 1. 4 times 1 is 4 minus 5. Oh, 5 minus 5. Nice. The first one we tried works. Thank God. Sometimes you do like 3 or 4 of them and then it finally works, and that sucks. Yeah. Yep. It's not charging. It's at 5%. So we'll see if we can make it 18 minutes. Yep. That's just how it goes sometimes. I tried to click out of it faster so you guys couldn't see it, but I normally don't have my iPad charged, but what sucks is it doesn't charge on this. So like last year, I just would sit next to the outlet. Now I'm sitting next to the computer, but it's not charging. But if I plug it into the wall, it doesn't go through. You know what I mean. 2020 problems, am I right? Okay, let's keep going. So 1 works. 1 is my 0. So my first 0 I'm going to make a list of, I'm going to write 1. I know there's going to be more, but 1 definitely works. In order for me to do more with 1, I have to do my synthetic division. So if you go back up to our list, if you don't remember, or if you like a list, I like to go off my list. Okay, check, I factored, couldn't work. Yes, I did my PRRs. Yes, I plugged it in to see what works. Now I'm doing my synthetic division. So we're going to synthetically divide with 1. So I'm going to do 1 in my little house. And then I'm going to do my factor or my coefficients of 1, 4. Oops, don't forget your x squared one. That's a common mistake, is if there's no x squared and we forget it, then you're going to get all of the wrong answers. So be very, very careful. So I've got 0, 1, 0, 4, -5. Carry down your 1. We've been doing so much synthetic division, you guys should be able to do this in your sleep now. 5, 5, 0. Perfect. 1, 1, and 5 become x squared plus x plus 5. If we want to go back to our list, we ask ourselves, okay, can I factor it or do I have to quadratic formula? This one we got a quadratic formula, don't we? X is going to equal -1 plus or minus radical 1 squared minus 4 times 1 times 5 over 2 times 1. Everybody doing okay so far? Yep. Okay. I get negative 1 plus or minus 1 minus 20 over 2. Move this up. This is way far down. If I've got 1 minus 20, that becomes negative 19. So I've got negative 1 plus or minus radical negative 19 over 2. Then what? You take out an I. The whole thing about this section is it's complex numbers. So most of my answers are going to have an I in them. We just have to be ready for an I. So an I is totally okay. That's my 0. I've got 2 zeros right here. Negative 1 plus or minus I root 19 over 2. Questions on that one? Any concerns? So again, we couldn't factor, so we did our PRRs. We found a 0, synthetic division, and then we quadratic formulaed. There's a lot of steps here, but I don't think independently they're hard. Just remembering them all together can be challenging. Okay, are we ready to move to B? Okay, flip your paper over. Parker? You can, unless I give you this on a non-calculated part of the test. Yeah, yes. Mm-hmm. The only thing though, Parker, is you won't be able to find I on your calculator. Absolutely, yeah. And so that's why yesterday, remember, we went back to 2-3, the one that I made us do in the calculator, and we confirmed it there. Yep. All right, next one. Okay, question 1, can I factor? No. 10, 44, 69? No way. Number 2, PRRs. Make a list of my possible rational roots. P's over Q's. I did, this P is 69, which is kind of a big number. That's okay. Our factors, there aren't that many factors to it. Jared?
What if there's like a 3 would you then do the factors of the answer that you divided?
Jared's asking a really good question. So he's saying, what happens if there was like a 3 out front here? We would still list our factors of 69 on top. So that'd be 1, 3, 23, 69. I'm just putting the numbers there so we can see it. And then factors of 3 is 1 and 3. All of our factors so far have been 1. So they've just all been the whole numbers, which is why I rewrite 1, 3, 23. Oh, God. What are you doing? Okay. And then 69. And then normally I'm done. But if I had 3 on the bottom too, I need to divide all the numbers on top by 3. So then I would also have a possible rational root at 1/3 or at 3 divided by 3. But 3 divided by 3 is 1, so we already counted that one. 23 divided by 3. And then 69 divided by 3. Oh, well, that's 23, so we already counted that. So if there was a number out front, we would have to count those as well. Does that answer your question, Jared? It's a lot, isn't it? Yep. But that's why we didn't do that on this one. We don't have any fractions on here. Also, if you are given a fraction, try something else first. Try 1 or 2 or something before you try that fraction, because I bet a whole number will work before that fraction will work. Okay, so we're going to try these. Let's actually divide and conquer. So let's do, girls, you try +1. Boys, you try -1. I'll try 3. If you get done with yours before everybody else, then you try 3 or -3, okay? I'm pretty sure 1 and -1 don't work, which is why I'm having us try the other ones. Again, just plug it into your equation. Which one? Yeah, who makes the most noise who's not here today? Who? Oh, so we're gonna blame it on Patrick. He's here to defend himself. Someone got someone like that last period. They were like, they were physically here, but mentally not. And I was like, whoa. In this hallway? Be here even if you're not here. It really seems to have made an impact on your life.
It did.
Good enough. Okay. Did anyone get 1 to work? Did you get -1 to work? It's 3. 3 works. 3 works. Now, what's unfortunate is if 3 works and you're by yourself on like a quiz or test, just be very careful with your steps to make sure you're testing everything, but it usually is one of the smaller ones. Don't jump all the way to 23 if you don't have to. Try and do 1, -1, 3, -3 first.
I've got one more question.
No more questions.
What is the number on the end was like smaller than the number in front? So the P was smaller than the Q.
Good. So Jared's asking about P's in the Q. So what if it was like 5x to the third, blah, 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 and then +1? That's okay. You're probably just only going to have fractions as your possible rational roots. So I would still have plus or minus my factors of 1, and I'd have plus or minus my factors of 5 on the bottom. So my possible rational roots would be 1, or positive or -1, and then positive or -1/5. How many numbers do you have to what? Factor wise. So you list as many as you can, because if you have to try more than 1, then you want to have a list to choose from. But like this one, 69 only had 4 factors. 2 only has 2 factors. So it's just whatever you have. Okay, so 3 works. So let's plug 3 in our synthetic division, and let's see what happens after that. Oh, somebody left. Bye. All right. Sometimes they leave because their internet goes out. I'm not going to blame anyone. I've also been on a Zoom and I know how to lie too. We all have been there, but I can't tell you what's true or not. So I choose to trust you guys for the better or for the worst. All right, bring down my 1, multiply. I'm going speed round now. Everybody with me? -7, -21. Are those the numbers I got earlier today? Okay, sometimes the numbers stick in my head and sometimes I'm like, I don't remember that at all. Did I do that wrong? Oh, perfect. 69 gives me 0. Okay. Now we got to write this in factor and with, oh. Are you good?
Yeah, I'm good.
Okay. X squared minus 7x plus 23. All right, I'm going to ask myself, can I factor this? Can you factor this? No. Quadratic formula. Yeah. Yep. Oh, Brooke got left out. She's back. Yeah, and then she came back. Patrick, your presence is requested. Are you with us, Patrick?
Yeah, I'm here. I was making food.
Oh, Patrick is making food. Your buds in the back say hey.
Okay, Patrick.
And Will just said, okay, Patrick. It's just like you're here, Patrick. Now he's like, please stop talking to me this way.
I'm still here. I'm still making food, though.
Oh, what are you making us, Patrick?
I'm making sausage.
Sausage? At 2 p.m.? I cannot. Is this class over yet? Oh, okay. Oh my
Wait,
God. Brooke, what's
I'm
up?
confused. My thing like kicked me off, and now I just don't know where we are.
Okay, we're on letter B on number 3. You just left like 2 minutes ago, so we should still be on the same path.
Yeah, but like what? Why are you doing a 3 now?
Perfect. Great question, Brooke. So you missed when I had try different numbers. So I told the boys
Yeah.
+1 and the girls to try -1. And then I said, I'll try 3. So we're hitting all the numbers we can. And 1 and -1 don't work, but 3 did. So when I plug 3 in, I get out 0. And then I do synthetic
Okay.
3.
Thank you.
Welcome. And then once I solve that, now I'm doing my quadratic formula. So I'll zoom back out in a second, but I got to zoom in so I don't write too trashy over here. It becomes +7 plus or minus 49 minus 4 times 1 times 23 over 2 times 1. All right. If I did 49 minus 4 times 1 times 23, that's going to give me -49. You guys trust me on that? Yeah, you're not going to argue with me on that? For real? I got 49 minus 92, which is, oh, did I do it wrong? You might be right. You might be right, Parker. Maybe you're right. Minus 49. Yep, 43. Oh, this didn't work out as pretty as I wanted it to. That's a bummer. Okay. I wanted it to be nice and pretty with a negative or with a 7i, but I guess it doesn't do that. So you can't make the math problem do what you want. What do I have to do with my last step here? Pull out I. I can't pull out anything else. I just get root 43. 7 plus or minus I over root 43 divided by 2. And that and 3 are my zeros. So I'm going to write them over here, zeros. 3 and then 7. What are you doing? Plus or minus I root 43 over 2. Okay, we're gonna hit number 3 or letter C tomorrow. And if I want to multiply that out, if I feel like that's valuable class time, we'll do that tomorrow. But other than that, all we're doing is reviewing. So we have learned just about everything you need to know. Now, I have not officially assigned 2-5 yet. I suggest you work on it and your 2-2 and 2-4, which are due tomorrow. I suggest you work on them to prepare you for this quiz, but I'm not assigning 2-5. What's going on here? Not 2-3. We already quizzed on 2-3. So Anaya just asked a good question. Your quiz is on 2-2, 2-4, and then 2-5. It's not going to be a long quiz, and these have a lot of parts to the question, so it will probably not be super long. Come with questions on Friday, because I'll start class answering questions. And then did I tell you that we were going to do it on Class Kick? Yeah. Okay. Sorry, that all classes mesh together. And so those of you at home will do it there as well. All right. Any questions from anyone on Zoom? Okay. If you
I don't have any, but I might email you later because I did have a question on the homework.
Perfect, Janae. So I'll look for your email. And those of you who
Okay.
are new at home, please let me know if there's anything I can do to support you too with the Zoom or with questions via email or whatever. So I know it's weird not being here, but I miss all of you, even those of you who are normally on Zoom. Please let me know if I can help you at all. If you don't have any questions,
Thank you.
I'm ready to go, and I'll see you later.
See you, Dawn.
Thanks.
Bye.
Okay, so do we think that's right?
Uh-oh. Uh-oh, he fell asleep. Oh, that's awkward. That's awkward.
I do think this every class when people don't leave. I'm like, hey, Patrick, any questions? and then they don't answer me, and I'm like, "You guys good over there?" I just talk to myself.
He's making the glizzy. Let him be.
Oh my god.
My bad. I was eating.
Welcome
you
back,
have-
Doyle.
Do you practice in an hour? This is
Yeah.